Good morning, class. Hope everyone's having a good day. I just wanted to send out a video. This is section 11.1 of our notes that you'll get an assignment on tomorrow. So our objective is that we're going to draw today and analyze three-dimensional solids. This is different than the rest of the year. We've been in two-dimensional territory basically the whole year. Aside from really chapter 1 and 2 and a little 3 lines. Lines are only one dimension and points are no dimension. But we're in 3D here, which means we're going to see a connection of two-dimensional shapes that take up space in our three-dimensional world. So we're going to draw and analyze three-dimensional solids, starting with the definition of what a polyhedron is. A polyhedron is a solid, three-dimensional solid that's bounded by only polygons. Okay, and so you can see here a rectangle. This is a bunch of rectangles put together. This is called a rectangular prism. We'll talk about a prism versus a pyramid here in a minute. But every polyhedron has a face, which is a two-dimensional shape that represents one of its sides, if you will. Some people will call it a side, but we want to refer to it as a face. Then every polyhedron also has an edge, or a certain number of edges, and edges is where each of the faces are meeting. And then polyhedrons also have vertices, which is where the edges are meeting one another, right? Points called vertices. All right, so now a polyhedron, solid bounded by polygons, okay, and there are two types of polyhedron that really we care about. There are ones called prisms, and there are ones called pyramids. Okay, prisms have two bases, and then a bunch of other rectangular faces depending on what the bases shape are. So two bases, and then all other faces are rectangles. I will draw that here in a minute. Okay, but write that down. Two bases, and then all the other faces are rectangles. So for instance, if we had, I'm going to draw a pentagonal prism, okay? A pentagonal prism starts with a pentagon and another pentagon, which I'm going to draw. Oh boy, I'm going to have to. Okay, and then you're going to connect. When you want to draw three-dimensional shapes, you start with, or three-dimensional prisms, start with drawing the two bases, and then connect all the vertices that would correspond. Watch what happens here. Now, this looks a little bit crazy until I do some erasing. Give me a second. That's a better spot. When I do some erasing, or not some erasing, but some dashing of some lines, you're going to see that it's pretty easy to tell how this shape looks. So I'm going to dash that shape, that edge, that edge, that edge, that edge, and you're going to see that now we have what's called a pentagonal, write this down, a pentagonal prism. You name prisms based on what their base shape is. A pentagonal prism. It's got two bases that are both pentagons, and look at the rest of the faces. The rest of the faces are rectangles, the ones that are stretching horizontally from one pentagon to the other. Okay, this would be a pentagonal prism. Okay, a pyramid, and by the way, there's things like a here would be a rectangular prism. Rectangular prism, like a Kleenex box or something, or a shoe box, would have not only not only just the horizontal faces are rectangles, all faces would be rectangles here. So we can have different types. A cube is basically a square prism. So we can have all sorts of different types of prisms. A trapezoidal prism, I think, is right here. Trapezoidal prism. And let's see. So now let's get into pyramids. Pyramids don't have two bases, they have one base. Okay, and then all the other faces are not rectangles anymore, they are triangles. All other faces are triangles. Okay, so what I mean by that is if I draw a pyramid, let's get down to drawing like a rectangular pyramid. I'm going to start by drawing a rectangle, but watch, I'm going to flatten it out. I'm going to flatten it out because it's sitting on a ground, if you will. Then I'm going to take and put the point of this pyramid right there, and I'm going to connect the dots to all the faces. And again, this looks a little bit trippy to the eye until you do some erasing. I'm going to make this one dashed, and this one dashed, and that one dashed. And then you can kind of see, especially if you take and thicken up these lines, you can see the pyramid here. Okay, so this would be called a rectangular, whoopsies, rectangular pyramid. You name it with its base, but obviously all the other faces are triangles, goes up to one tip. It's called a rectangular pyramid. Okay, now these are polyhedron solids bounded by polygons. Here's some three-dimensional solids that are not polyhedrons. Watch, or polyhedra. A cone, because it's got a circle as a face. Cylinder, same thing. Sphere, same thing. Not bounded by polygons. So although they're three-dimensional figures, and we still care about these are very real shapes, they're not considered polyhedron. Okay, so like we said, pyramid versus prism, and we characterize solids by the shape of their base. So a pentagonal prism versus a pentagonal pyramid is shown here. Okay, now let's see. There's this theorem I want you to write down. This guy named Bernard Euler, he figured this thing out, that in any polyhedron, the following equation is always true. The number of faces plus the number of vertices will always equal the number of edges plus 2. That's kind of cool. Okay, the number of faces plus the number of vertices will always equal the number of edges plus 2. All right, I'm going to show you that. In a cube, let's just verify that that holds true in a cube. So if we draw a cube, we don't even really need to dash lines and stuff. We're just showing that this cube is here. Okay, how many faces are on a cube? There's clearly 6 faces because we've all rolled a dice before. How many vertices are on a cube? Well, let's count. 1, 2, 3, 4, 5, 6, 7. There are 8 vertices on, this bothers me that I put a colon but then an equal sign. Whoops. Better make them colons. Okay, how many edges does this cube have? Well, let's just count. Okay, we got, I might do this in purple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges on a cube. Okay, so now let's make sure that, let's verify that this holds true. Faces plus vertices equals edges plus 2. And let's make sure. Faces, 6. Vertices, 8. Edges, 12. And you'll notice 14 equals 14. This guy Euler is pretty smart. So you'll be able to use that equation to be able to, if I tell you the number of faces and the number of edges of a polyhedron, how many vertices does it have? You simply plug it in using this formula. You'll be able to find it. Okay. The last thing in this section that I want to talk to you about is I want to talk to you about cross sections. Cross sections, write this down. You can even draw a cone to start with. Cross sections are basically cuts that we can make in a shape, and revealing like what shape gets created when we make a cut. So for instance, Okay, if we were to make a cut vertically, vertically on this cone. So if we were to take like a steak knife, if you will, all right, we had like, I don't know, a loaf of bread or something, or like a styrofoam that in the shape of a cone, and we were to cut right down the middle, okay, and then we were to take these two pieces and open them up, okay. What would happen is you'd have a face inside there, right, that you'd be able to see. Okay, it's like a piece of bread of a loaf. If you were to take this cone, cut it, open it up, what is the shape of the face that would be looking at you? And the answer to this is that you would have a triangle. When you make a vertical cut in a cone, you would have a triangle staring at you when you cut and open it up. And it actually wouldn't matter if you went right through the vertex, or if you went and you made this cut right here. If you make that cut as well and open it up, it's still going to be a triangle when you look at its face. Now, so vertical cross section would be a triangle. Horizontally, though, watch this. Right, just take an eraser. If you were to make a horizontal cut in this shape, let's say right about there, okay, and you were to open up, now this is a cone, okay, a cone has a circle as a base. So if you made this cut right here and opened it up, what would be staring at you when you open that up? It would be another circle. That's a circle in there. It's a circle that gets progressively smaller as you work it your way up. All of a sudden, like if you make this cut up here, a really small circle when you open that up. Okay, so a horizontal cross section here would be a circle. So in the questions that ask about cross sections, you know, vertical cross sections or horizontal cross sections are really just talking about like what's the shape, the two-dimensional shape of a face that would be staring at you when you made a cut in some direction and then opened this shape up and took a look at it. Okay, that's what cross sections are. That's what I got for you in section 11.1. Hope you're all having a great day. You'll have homework on there tomorrow. See ya.